Hi there. So I guess this is now the fifth installment of the electric BMW 320i project. So for this week I'll show you what I've been doing on the car. Mostly it's been just running the wiring, the high current, high voltage cables, and how that's laid out. And the other thing I've been working on is I have these 120 batteries that I need to bottom balance. Well, before bottom balancing they need to be fully charged and then discharged. And I thought it was kind of wasteful to just put that energy right into a resistor or a lamp. So the idea I had was to get one of these inexpensive grid-tied inverters. You see them advertised all over on eBay. I'll show you one here on this shot here. Anyways, looks like they're great. They're rated, you can get them up to 2,500 watts, and they should be perfect. And that seemed like it'd be ideal to draw about 30 amps out of the batteries and pull it right down. So I got one of these. I got one of the 2,500 watt ones and connected it up, and sure enough it pulled that out of the batteries. It ran for about 2 hours, pulled the whole battery pack right down. I have a watt meter on my house. I could see it putting 2.5 kilowatts back into the house. Worked really well. So then I set the video camera up, and you'll get to see what happened at that point. The other thing I've been working on is this battery monitoring system that uses this new Sendine chip, and I'll be talking about that at EVCon in a month, and I'll show you how that's going. So let's take a look. Here's what's new with the electric BMW 320i project. Started running all the heavy battery cables. What was really a great find was that these rocker panels are totally hollow from the very front up to the kicker all the way to the back, and so made a very great channel to run battery cables through. And just there were already holes drilled. I just had to make them a little bit bigger, and got some nice edging that I was able to find online with the Master car to align those, and then using gland nuts to go through to the firewall. You can't see it. And that channel runs all the way underneath the door, all the way back to the area here where the battery box is going to go. And so one cable is for the into the battery, and then the other cable's out, which goes to the trunk. And again, this piece of conduit that was left over from the gas line, I guess that was a vapor control line, makes a great conduit for the thick battery cables. One thing I found that is if I drilled the hole just right, diameter, that these 1-inch gland nuts that are for the battery cables actually screw right into the sheet metal. And make a nice seal, just like if you had screwed a nut on the other side. So that's the channel. Again, goes from front to back of the car. Great way to run these battery cables. Out of the way, we'll be protected from the elements, and we'll protect the occupants from the high voltage and current going through the cables. Got the same going on the other side. Again, that rocker panel channel, which goes from front to back on the passenger side, does the same on the driver's side. Same deal, again going back up in the trunk, and so again using the gland nut screwed right into the sheet metal. That cable goes right underneath through the rocker panel and comes back out, and then that will have to go up underneath the dash. See, the instrument cluster is still out. Oh yeah, and also notice the seats have been removed. It does make working on this a lot easier. Unfortunately, what I found when I started pulling around on the carpeting and pulling up on the various things to get the cables through, I discovered that the carpeting underneath the passenger side over here, the insulation actually below is still wet. Apparently there's been a leak in the somewhere in the top area for quite a while. I did notice when I took that that ECU box out that it was pretty badly corroded, so that leak has been something that's going on with this car for a while, so I'll have to fix that. But the biggest implication now is that the carpeting is going to have to be replaced, because that is going to eventually mold. Now here's a look at the first set of cables coming into the engine compartment, and see how it mock up to the front battery box and how it will connect to that. And the only problem with the other side is that the vacuum boost for the brakes, that's going to have to be removed to be able to get the cable through and on a gland nut and brought through into the engine compartment. So kind of a still a bit of work to do there. Here shows something else I'm going to do with this wire. The high current cable that's coming into the passenger compartment is cover it with this power braid. It's something that Summit Racing sells. Really strong reinforced braiding, split loom sort of, that I wrapped around, and just to further protect that cable that's inside the passenger compartment here. Here's something else I'm working on. I have a Sendyne, another Sendyne EVB evaluation unit, but this one is connected to an external shunt. This is a Deltec 100 millivolt shunt. Their normal evaluation unit comes with a 100 millivolt shunt, but that's only a 150 amp shunt. This Deltec is a 600 amp shunt, which will be perfect for my car. So what I'm testing out is the ability of the Sendyne to have an external shunt. They said it would work, and I have a way to test this out. So what I have is batteries connected up to it's called a grid-tied inverter. And basically what I'm doing is using this grid-tied inverter to drain the batteries down after I charge them, so I can bottom balance them. This also gives me an opportunity to measure high currents and see how the whole system performs. So the way this starts out, so here's the Sendyne application running, showing that the battery voltage is at 75 volts, which I had to strap it up that way because the grid-tied inverter is only good to 80 volts. What I also got set up is this power monitor for the house. You can hear in the background is actually the noise of the air handler for the air conditioner. So the air conditioner is cranking right along, and you can see at 8, that's reading 8 kilowatts. So basically when I close the contactor, and then turn on the inverter, and see the current ramps up. It'll pull about 26 amps off the battery when it gets to max point.
What the fuck?
Well, here's what's up with that grid-tied inverter. You probably heard me exclaim a little bit there when I heard a large electrical pop, and it turns out one of the MOSFETs back here in the corner totally fried, and that's what the large discharge noise was. I went and measured all of the devices, all the MOSFETs, and it turns out about half of them are open. It had a couple sets of DC fuses, those were totally blown. The AC fuses at the front seem to be working, but looking at this is really a very marginal design. I mean, the DC fuses were standard automotive 32 volt fuses. Now this is supposed to be rated up to 80 volts, and that's crazy to have that kind of fuse in this system. You know, this is the kind of thing that would burn somebody's house down. I know a lot of people are buying these because they're very cheap inverters to tie to your solar panel and then tie that into your house AC, but this kind of thing, that's a problem. Really could cause a fire. Here's the battery monitoring system main board. You can see it pretty much is the same form factor and physical layout as the JevQ. Has the 35 pin connector up front and the USB out the back. Biggest difference is all the chips that are on it. They're designed to interface to the Sendine board, and that's what's plugged in on top. I showed that earlier working with this Deltec shunt as an external shunt. Seems to work pretty well. It's not running any code on this yet. This only has a rudimentary program running to make sure everything is just up and connected correctly. But the Sendine will sit like that. It plugs right into the board. And this board can do a whole bunch of different things, and I will be talking about that at EVCon. The work I'm doing with that is some breadboard work to develop the what we're calling the high voltage mux, which is to be able to mux in or multiplex 4 different voltages from the battery, and trying to do that with some MOSFET switches, and we'll see how that works out too. So the unfortunate incident with the inverter sitting here on the bench, so I guess you get what you pay for. I'm just surprised that those things are so built in that fashion. I mean, people are buying those, like I said, to use their solar panels so they can bring the energy back into their house, and you know, something like that could, like I said, catch fire and burn your house down. Should have also known when I was looking at these that they have online the whole kit of MOSFETs to repair them. I thought that was very interesting, but now I know why. And you can see this is kind of ridiculous. It's about 70 bucks in MOSFETs to repair this module, when the module itself only, this one cost $400. So, you know, I guess I'll just keep repairing it and seeing if it breaks. I don't know if what really made it fail. One possibility is that at the time the air conditioner was running, which I noted, and it could be that that high inductive load may have imbalanced the AC, and enough of that could have caused these things that don't have a real good control over the AC to freak out. Although it was really the DC end that blew up and not the AC end, so I'm not really sure what the problem is there, but I'll keep working at it, and because I think it's really a great way to discharge the batteries, and you know, as long as you're around and you can watch it, make sure it doesn't catch on fire. It's probably the best way to go. So thanks for watching, and I'll see you next time.